Hello dear student, welcome to new session of Newton's laws of motion. It's your 8th lecture. In this lecture we'll discuss about frame of reference. So let's check it out what actually frame of reference is. So my dear student, frame of reference is nothing but observer. Frame of reference is nothing but observer. I'm repeating once again. Frame of reference is nothing but observer. So see my dear student, basically frame of reference is defined as on condition of observer. So write down frame of reference is nothing but observer. 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 Next point, my dear student, the condition of observer, and we know that what actually observer is. Observer is the way how we'll see the object. The person who is seeing the object is called observer. So observer is on two different conditions. Write down next point. Observer is on two different conditions. Observer is in two different conditions. Observer is in two different conditions. Full stop. Next point. On the basis of condition of observer, frame of reference is classified on the basis of condition of observer, frame of reference is categorized into two types. Frame of reference is categorized into two types. See my dear student, on the basis of observer, we can categorize frame of reference into two types. Now what actually condition of observer is? In some cases, observer is in motion, and in some cases, observer is at rest. So on the basis of condition of observer, frame of reference is also categorized into two types. Frame of reference is also categorized into two types. First frame of reference is inertial frame of reference. First is your inertial frame of reference and second is your non-inertial frame of reference. First is your inertial frame of reference and second is your non-inertial frame of reference. So see, a frame of reference is nothing but considered to be observer. And my dear student, observer is in two different conditions. One is observer is in motion and second observer is at rest. So on the basis of condition of observer, that is in motion or in rest, frame of reference is also categorized into two types. First frame of reference is inertial frame of reference and second type of frame of reference is non-inertial frame of reference. So remember, frame of reference on the basis of condition of observer is categorized into two types. First is inertial and second is non-inertial frame of reference. First is inertial and second is non-inertial frame of reference. Now check it out what actually inertial frame of reference is and what actually non-inertial frame of reference is. So write down explanation of types of frame of reference. 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 Now see, my dear student, frame of reference means observer. Frame of reference means observer, and as I already tell you, observer can be classified into two different conditions. First is maybe observer is at rest, and second, observer is in motion, or we can say at motion. So frame of reference is nothing but observer, and there are two different conditions of observer. In some cases observer is at rest, or in some cases observer is in motion. Now see, actually motion is also performed by observer in two different conditions. In first condition we can say motion is with constant velocity. In first condition we can say motion is with constant velocity, and in second condition we can say motion is with variable velocity. So my dear student, observer, condition of observer is of two types. Either observer is at rest or observer is in motion. In motion as well, my dear student, there are two different conditions. First condition is maybe the velocity of motion performed by observer is constant, or it may be variable. So see, basically frame of reference is nothing but observer, and observer condition is of two types. Either the observer is at rest or the observer is in motion. And again, motion is also of two types, with constant velocity and with variable velocity. So dear student, basically frame of reference is categorized into two parts on the basis of condition of observer at rest, at motion. Motion is again of two types, constant velocity and variable velocity. Now we all know that acceleration is nothing but change in velocity with respect to time. If velocity is changing with respect to time, then the particle, or we can say then the body, acquired acceleration. Now see, if the observer is at rest, then velocity is 0, and if velocity is 0, then acceleration is not present. So we can say acceleration is equals to 0. Similarly, if the observer is in motion, then with two types of, two category of motion can take place. We can say one category is with constant velocity and other category is with variable velocity. Now check it out. If velocity is constant, then we know that acceleration is nothing but change in velocity with respect to time. So if velocity is constant, then again, my dear student, velocity is not changing, so we'll get zero acceleration, because until and unless velocity is not changing, acceleration becomes equals to 0, as the relation of acceleration is change in velocity with respect to time, that is dv by dt. So observer, frame of reference means observer, at rest, velocity 0. So if velocity 0, then acceleration, it is but obvious that it is equals to 0. Second, motion with constant velocity and motion with variable velocity. So if velocity is constant, then acceleration is equals to 0. But if velocity is variable, then acceleration is not equal to 0, because velocity is changing, and if velocity is changing, then particle acquired acceleration. Now see, my dear student, observer at rest, at motion with constant velocity with variable velocity. In this condition, when particle is at rest, then also acceleration is 0. And if particle is moving with constant velocity, then also acceleration is 0. So we can say these two conditions are similar, because in both condition acceleration is 0. If observer is at rest, then also velocity is 0, so acceleration is 0. And if it is moving with constant velocity, then also velocity is changing, velocity is not changing, hence acceleration is 0. But in this condition, when velocity is variable, it means velocity is changing with respect to time. It implies particle is accelerating. In this situation, acceleration is not equal to 0. So what we will see, if particle is at rest, then also acceleration is 0. If particle is moving with constant velocity, then also acceleration is 0. So we can say these both conditions is same and this condition is different. So my dear student, remember, when the observer is not accelerating, write down, when observer is not accelerating, remember this thing, if observer is not accelerating, that is either observer is at rest or if moving, then move with constant velocity, this kind of frame of reference is called inertial frame of reference. Inertial frame of reference. And if acceleration is not equal to 0, so if acceleration is not equal to 0, means acceleration is acquired by observer. So this kind of frame of reference is called non-inertial frame of reference. Non-inertial frame of reference. So my dear student, on the basis of acceleration of observer, frame of reference is categorized into two types. If acceleration of observer is 0, that is either observer is at rest or moving with constant velocity, then the frame of reference is said to be inertial frame of reference. And if observer is accelerating, that is the velocity of observer is changing, or we can say acceleration is there with observer, then the frame of reference is said to be non-inertial frame of reference. So remember, frame of reference is nothing but observer. So write down inertial frame of reference. Write down inertial frame of reference. Inertial frame of reference. So if the observer, write down inertial frame of reference. In inertial frame of reference, we can say if the observer is at rest, or moving with constant velocity, if the observer is at rest or moving with constant velocity, if the observer is at rest or moving with constant velocity, here comes inertial frame of reference. So inertial frame of reference is if the observer is at rest or moving with constant velocity. If the observer is at rest or moving with constant velocity, then the acceleration of observer is said to be inertial frame of reference, So remember, my dear student, the acceleration in inertial frame of reference is 0. If the observer is at rest or moving with constant velocity, then the acceleration of observer is 0 and it is said to be inertial frame of reference. and it is said to be inertial frame of reference. So remember, if we are talking about inertial frame of reference, it implies the acceleration of observer is 0 and it achieves in two different conditions. One, either the observer is at rest or with moving with constant velocity. Similarly, write down non-inertial frame of reference. Non-inertial frame of reference. Non-inertial frame of reference. So write down, if the observer is accelerating, if the observer is accelerating, if the observer is accelerating, then the frame of reference, then the frame of reference is, then the frame of reference is said to be, then the frame of reference is said to be non-inertial frame of reference. Then the frame of reference is said to be non-inertial frame of reference. So my dear student, remember, frame of reference is nothing but observer. The condition, on the basis of condition of observer, frame of reference is categorized into two types. One is inertial frame of reference and second is non-inertial frame of reference. So in inertial frame of reference, we can say the observer is not accelerating. That is, either the observer is at rest or the observer is moving with constant velocity. When we are talking about inertial frame of reference, then remember, acceleration of observer is always equals to 0. If we are moving towards non-inertial frame of reference, then non-inertial frame of reference is nothing but accelerating frame of reference. So in this condition, the observer is in motion with variable velocity, or we can say the frame of reference which is accelerating frame of reference is called non-inertial frame of reference. So write down expression for inertial and expression for inertial and non-inertial frame of reference. Expression for inertial and non-inertial frame of reference. Expression for inertial and non-inertial, inertial and non-inertial frame of reference. Expression for inertial and non-inertial frame of reference. Expression for inertial and non-inertial frame of reference. So see my dear student, actually let's suppose if we have an object of mass m, and I am asking you draw the free body diagram of this object. So if I am making the free body diagram of object, then it will be vertically downward mg and in upward direction there is a force called normal. Now see my dear student, basically this free body diagram is made by me, so I am the observer. I am repeating once again. If there is a block placed on a horizontal plane and I am making the free body diagram, then I am basically observer, and observer means frame of reference. So basically I am standing here and making the free body diagram. It means this free body diagram is made by observer at rest condition. At rest condition. Remember my dear student, if I am standing here and making the free body diagram of this object, it means mg is vertically downward, normal is upward, and I am making this free body diagram. So I am frame of reference because I am the observer and I am making this free body diagram under rest condition. Under rest condition. So if I am making free body diagram under rest condition, it means I am making this free body diagram under inertial frame of reference because my acceleration is 0. If my acceleration is 0, then I am at inertial frame of reference and I am making this free body diagram under inertial frame of reference. What if I am under non-inertial frame of reference? Because till now we are making all the FBDs under inertial frame of reference. Now we learn how to make free body diagram under the condition of non-inertial frame of reference. So write down, my dear student, free body diagram under the condition of free body diagram under the condition of free body diagram under the condition of non-inertial frame of reference. Free body diagram under the condition of non-inertial frame of reference. Free body diagram under the condition of non-inertial frame of reference. Free body diagram under the condition of non-inertial frame of reference. Free body diagram under the condition of non-inertial frame of reference, and we know that non-inertial frame of reference means observer is accelerating. So check it out, my dear student. Let's suppose we have two observers, S1 and another observer is S2, and there is a particle which is present at point P and the mass of this particle is m. So my dear student, let's suppose we have two observers, S1 and S2. Both the observers are standing here, but they are in different conditions. Let's suppose the S1 observer, S1 is at rest. So if S1 is at rest, then its acceleration is 0, and let's suppose S2 is in motion. S2 is in motion with acceleration a. So my dear student, if S1 is at rest, it means the acceleration of S1 is 0. So S1 is in inertial frame of reference because its acceleration is 0. And if I am talking about S2 observer, then S2 observer is accelerating, means its acceleration is not equal to 0. So we will say S2 observer is in non-inertial frame of reference. So let's suppose, my dear student, let's make the Cartesian system for both the observer. It is like this. I am making the Cartesian system of both the observer. Now see, S1 is at rest, so its acceleration is 0, but S2 is in motion with variable velocity, so we can say this is accelerating. Now let's suppose both the observer see this particle which is placed at m having mass m. So if seeing the object, let's suppose I'll make the position vector of this object, because we have Cartesian system and we know that if we have Cartesian system, then we have also its coordinates, and if coordinates is given, then we'll make the position vector. Now see, my dear student, this is the position vector drawn by S1 with respect to P. So I'll write position vector of S1 with respect to P. I'll write position vector of S1 made by P. Position vector of, it will be like, write this, position vector of P made by S1. Similarly, I'll make position vector of P seen by S2. So I'll write position vector of P made by S2. Similarly, let's suppose S1 also sees S2. So position vector for S2 made by S1 with respect to S1. I'm repeating once again, I'm drawing the position vectors, my dear student. I'm drawing the position vector. So this is what position vector of P drawn by S1, position vector of P drawn by S2, which is in non-accelerating frame of reference, position vector of S2 drawn by S1. So my dear student, we'll make position vector we'll make position vector for P drawn by S1, position vector of P drawn by S2, position vector of S2 drawn by S1. Now see my dear student, here we form a triangle whose all the three sides are vector. It is like this. So this is basically position vector for P drawn by S1. This is basically position vector of S2 drawn by S1, and here it is position vector of P drawn by S2. So this forms a triangle whose all the three sides are vector. So I'll apply by triangle law of vector addition. By triangle law of vector addition, and we know that what is triangle law of vector addition? Sum of two regular vector is equals to third vector. Sum of two regular vector is equal to third vector. Sum of two regular vector is equals to third vector, and meaning of regular vector means combination of one vector head and second vector tail. So see my dear student, this is the head of position vector of S2 drawn by S1. This is the tail of position vector of P drawn by S2. So these two vectors are regular. So sum of these two vector is equals to third vector. So I'll write position vector of S2 drawn by S1 plus position vector of P drawn by S2 is equals to position vector of P drawn by S1. Position vector of P drawn by S1. Now my dear student, I'll differentiate it with respect to time. So we know that if I'll differentiating position vector with respect to time, so we'll get nothing but velocity, because we know that dr vector by dt is velocity. So let's differentiate this function. So differentiate with respect to dt. What we'll get? d over dt position vector of S2 with respect to S1 plus, draw the, differentiate this. So what we'll get? Check it out. Plus differentiation of position vector of P with respect to S2 with respect to time is equals to d over dt r P vector by S1. Now see, basically this is position vector of S2 drawn by S1. So I am drawing position vector of S, differentiating position vector of S2 of position vector of S2 by S, position vector of S2 by position vector of S2 by seen by S1. So we'll get the velocity. So velocity of P with respect to S1 is equals to velocity of S2 with respect to S1 plus velocity of P with respect to S2. Velocity of P with respect to S2. Now again we have to differentiate this equation with respect to time. So we know that if we'll differentiate velocity with respect to time, we'll get acceleration. So I am differentiating again it, differentiate with respect to dt. So velocity d over dt, velocity of P with respect to S1 is equals to d over dt, velocity of S2 with respect to S1 plus d over dt, velocity of P with respect to S2. Now we know that velocity with respect to time is acceleration. So acceleration of P with respect to S1 is equals to acceleration of S2 with respect to S1 plus acceleration of P with respect to S2. So this is basically acceleration. Now check it out. Acceleration of P drawn by S1 is equals to, see my dear student, S1 is basically in non-inertial frame of reference because S1 is at rest. So acceleration of P with respect to S1 is equals to acceleration of S2 with respect to S1. I mean acceleration of S2 drawn by, seen by S1, and acceleration of P seen by S2. So multiply this equation with mass. So multiply with mass. So we'll get mass into acceleration of p with respect to s1 is equals to mass into acceleration of s2 with respect to s1 plus mass into acceleration of p with respect to s2. Now we all know that, my dear student, mass into acceleration is nothing but force. So see, basically here mass into acceleration of p with respect to s1, mass into acceleration of s2 with respect to s1, mass into acceleration of p with respect to s2. So we know that basically force is nothing but mass into acceleration. Force is nothing but mass into acceleration. So check it out, my dear student. This is basically force, this is also force, and this is also force, because all are acceleration, and acceleration is multiplied with mass. So try to understand what I'm saying. Force is basically drawn by FBD. So instead of force, let's assume this to be in terms of FBD. So what I'll write, just check it out and try to understand, dear student. Basically in FBD we'll present forces. So instead of considering force, I am writing here FBD, because we know that in FBD forces is presenting. Forces are presenting. So nothing special here. Instead of writing force, I am writing FBD. So check it out what I am writing. I am writing here acceleration of p with respect to s1 means free body diagram of p made by s1, because here observer is s1, mass into acceleration is force, and in FBD we are representing force. So basically free body diagram of p made by s1 is equals to mass into acceleration of s2 with respect to s1 means free body diagram of s2 with respect to s1, or we can say made by s1 plus mass into acceleration of p with respect to s2. So acceleration of p with respect to s2 means FBD of p made by s2, my dear student. Now see, s2 is in motion, s1 is at rest. See, remember, right? Try to understand. This is basically FBD at rest condition, which we are familiar with this, because in previous cases always the FBD is made under condition of observer to be at rest. So this is basically in this condition, that is FBD of p made by s1 is at rest. So this FBD is at rest condition. This FBD is, my dear student, made by s2 for p, but s2 is accelerating. So we can say at accelerating condition. So this is basically new for us. So what we have to do, we'll learn how to make FBD in accelerating condition. So I'll transfer this equation in this side. So what we'll get, basically we are trying to understand how to made FBD under accelerating conditions. So if I'm taking this in this side, so what we'll get, FBD of p made by s2 is equals to FBD of p made by s1. This is normal condition, that is under inertial frame of reference. This FBD is under inertial frame of reference, plus mass into acceleration. So mass into negative of acceleration, because if you will take this in this side, so it becomes negative, but I'll write plus in form of plus. So mass into acceleration. Now see, basically this is FBD of s2 means FBD of s2, condition of s2 made by s1. So if S1 is seeing S2, then S2 says that this is in acceleration condition, that S2 is in acceleration condition. So this is basically FBD under how to make FBD under non-inertial frame of reference. FBD of P made by S2 means S2 is in non-inertial frame of reference because S2 is accelerating. So if observer is accelerating, then observer made FBD in inertial frame of reference means under rest condition, then he'll add one more force, mass into acceleration of observer, mass of object into acceleration of observer. Negative sign shows that this force will act on body in opposite to direction of motion of observer. What I am saying, my dear student, is try to understand this. This equation shows that if observer is accelerating, let's suppose a train is there. In this train, let's say an observer is sitting and this train is accelerating in this direction. The platform is there in which an object is placed. So now see, my dear student, if I am moving in train and in this direction, just imagine when you are sitting in train and seeing the platform and train is accelerating. What you will see? You will see the objects which is placed on platform is moving in backward direction, in reverse direction. If a train is moving in this direction, then you will see the objects which are placed on platform is move in backward direction. So if the observer is accelerating, means the observer is moving in this direction, then he'll make the FBD under rest condition. So this is mg and in upward direction normal. So this is basically FBD under rest condition. Then he have to make one more thing, that is the force in opposite to the direction of acceleration of observer and MA. So one more force is acting in this direction. This direction is basically opposite to the direction of acceleration of observer. See, my dear student, because this force is applying on this body because the observer is in non-inertial frame of reference. So in next class, my dear student, we'll discuss more about non-inertial frame of reference and what basically these forces is, why these forces are existing, what is the mechanism of these forces. Till then, dear student, thank you so much with connecting with us. In next class, we'll discuss more about, try to understand frame of reference and make your proper notes. Thank you so much.